Sorry about that. I'm thankful if you could stick around. My computer, the whole computer just crashed. So go figure. Anyway, it was 13 minutes from crashing to being back. So that was quite a while. So nice to see you, Rango. Thanks for sticking around. Yeah, I mean, like literally the computer just shut down. I've sort of had this sneaking suspicion that I've got a bad piece of hardware in it somewhere. So probably a new computer coming someday soon. So thanks for waiting. It crashed at 3:58 and took me until just now to shut it down, start it back up, wait for it to do whatever it does, and then get all the software running again. So crazy. Okay, anyway, so for those of you who could stick around, thanks for sticking around. Um, week 2, Programming Algorithms 1, CSCI 20. So we'll start just, you can see it in the notes there. So um, everybody in both sections had really good labs. So it didn't look, at least, like anyone had problems. And most people actually added extra outputs. So that was neat to see. That a lot of people tried to do an extra output and got an extra output, and that was very satisfying. And then just to try to get us to tighten things up. So in the documentation section at the top, these are formal college assignments. So you want to be formal in your documentation. And what I mean by that is put your entire name that you would use in any formal situation. Please use your name, not a nickname, not just your first name. But when you're documenting your work and submitting it, please your whole name. So anyway, a bunch of people got comments about that. And that's just to remind you that being more formal is better than less formal. So whole name on your assignments. There were one person did an interesting experiment just to see what happens if you do an output that runs super long over several lines, and what happens. So I have that in my notes, how to handle long outputs. And what you probably found is that the computer didn't do a very good job of making your outputs look nice. So we're going to do some work on how to make your outputs look nice tonight, how to control them like a programmer controls them. And what I mean by that is when your program is putting information out on the screen, you want it to look good. You want it to look polished. You want it to look like you purposely made it look like it's looking, and not just kind of crossed your fingers and hope for the best. So we'll talk about the ways to do that is a big part of what we're doing today in the live stream. So sorry, it's going to take me a moment to sort of get myself back from being fear and angry at my computer. Okay, so I'm just at a home page. There's 2 sections of you, of course, but your Canvas pages are the same other than the section number. I think I got it all fixed, but please, when you go into Canvas this week, just double check to see that the number that you are in Canvas is the number that you are in Piazza, and vice versa. So some of you are in section 7578, and that will show when you're in Canvas, and you should be in section 7578 in Piazza. And if you're in section 8849 in Canvas, you should be in section 8849 in Piazza. And I think I got everybody who needed to be cleaned up. But if not, please let me know and we'll get it cleaned up so that you're in the proper section. Okay, so just to remind you, the home page is where I try to make all the stuff that I try to make it easy for you to find information for the class. So the home page, of course, has all the ways that you can keep in touch with me. And then it has the schedule where you access content. Now, we do have a project coming up on September 18th, so I want to make sure we look at that today and talk about getting started on it. it's part of training in computer science to get used to, and in fact, in all fields of engineering, I would bet. It would be true that sometimes you get projects that require knowledge that you don't necessarily have at the moment that the project is handed to you. So, how do you begin to create a solution to a problem that you don't have all of the knowledge you need to solve it? So, that's one of the skills that we want to learn is how do I actually begin to build out a solution in increments over time as I'm learning the new things that I need to actually create my solution. And I'll talk a little bit about that today when we look at the individual project one, which note is due on September 18th, which is, I don't know, a little over 3 weeks away maybe. Okay. So let's walk through the module, and then we're going to end up working in REPL a lot tonight because we're going to look at a lot of code, because that's a lot of what the content for this week is how do we do certain things in the Go language in code. Okay, so some people think this is a good thing about programming. Some people think it's a bad thing about programming. But one of the things we're going to see this week is that the Go language provides a variety of different ways of performing the same task. Some of us like having choice. Some of us like that Go language will let us do tasks in a variety of different ways because it allows for different people to do different creative things. And some people are more comfortable sometimes if their tool just says this is the one way you do it and this is the way you have to do it, and that can be comforting. So the Go language, when it comes to the feature we are talking about this week, will allow you to perform a task in several different ways. All I can say is that you should experiment with the different ways of performing this task and see if one of them sort of feels the most comfortable to you. If one of them, when you look at it on the screen, you understand what it is, that you sort of, your mind remembers how to do that particular, perform the task in that particular way better than it does in the other ways that you could do it. And we'll talk about the specific task here in just a few moments. So you're going to see that there's a lot of choices when it comes to just the one task, really, that the main task we're doing this week, which is how do we store information in a computer program? And then we'll also spend a little bit of time talking about how do we take information that we stored in our program and actually print it to the screen, which is what this bottom part is about. So store information, show the information on the screen. There's a lot of reading. Many of these are just options for the reading. So what I hope will happen for all of you is that as you're going through the different sources, so we have Intro to Programming in Go, there's 2 readings. We have Go by Example, there's 2 readings. We have Golang programs, there's 2 readings. And then there's another Go by Example. So most of these readings are presenting the same things, just in different ways. So I hope that what you'll do is you'll sample all the different ways of presenting the information. And here we go again with the choices, right? But that you'll find one of these websites. So perhaps you go to Go by Example and you think, I like the way they present the information. I understand it better. Then you can kind of favor the Go by Example readings over the others if you find those work best for you. Or if you like Intro to Programming in Go, you think that's presented in a way that you understand best, then you favor those readings over the others. So kind of more working through the different choices for getting at the same task, which in this case is learning some new concepts. The homework, as always, it looks like everyone's doing fine overall in the homework. So no concerns there. And by the way, it's pretty unprecedented that I have about 60 students in Programming Algorithms 1, and I think one person didn't show up to do anything in the first week, which I assume means that they decided not to take the class, but didn't drop. So that's pretty neat. Okay, the lab. So I'm going to finish walking through the module, and then I'm going to come back to the lab and have it queued up for later in the live stream. The discussion. So this is one that you need to get in the habit of paying attention to. So there's not many instructions, but every week of the semester you will be asked to go to Piazza, find the link or the filter for the week that we're in. So this week is the week 2 filter. You click on, it's across the top, you click on the filter, you find the class discussion, which will already be started because I started all of them. So for doing the assignment discussion, you will always go to a discussion that I always started. So if you are starting a new discussion, a brand new page, and there's nothing else on it, that wouldn't be the class discussion. Now, you are welcome and encouraged to start discussions to ask questions about our labs and projects. But there's also always the discussion that I have started in Piazza that I would like you to contribute to. So you go to week 2, you find the discussion that has already been started, and you go down and you do a follow-up in it. You are also welcome to, and many of you did in the first week's discussion, you went and you replied to classmates and said hello and stuff, so that was great. But anyway, just make sure that you have a look at the instructions and make sure you're finding the filter and finding the discussion that's already started. And then reminders. So I'm going to go ahead and open the individual project one so I don't forget to talk about it before we leave today. So it's in there as a reminder because you want to look at it and begin planning to work on it soon. In fact, I would argue this week. Make sure you look at it and start thinking about how you're going to work on it. What you do know how to do, what you don't know how to do, so that you're mindful of the skills that you need that you can get from class and from homework and from lab to solve the project. Pardon me. We don't have exams in this class, so the projects more or less stand in for the exams. Okay, let me go back to the lab and I will have that ready when I want to talk about it. This is it. Okay, so I am going to switch to Replit. And I'm going to make a REPL just for lecture today. So I'm going to go ahead and create a REPL. And I'm going to say, oops, I need go. So this is a thing, most of you did this, but you don't want to just take the random title on your REPLs. It makes it look like you're not paying attention to what you're doing, especially when I've talked about it, and especially when the lab assignment actually specifically says to change the name of your REPLs. So almost everybody did it, but not everybody. So if you're one of the people who just took one of these random REPL names, that's something to pay attention for. It's part of what we in engineering and engineering related fields do is we pay attention to the details because we build things that other people use and the details are important. So let's get in the habit of paying attention to the details, which would include naming your REPLs according to what it is that they are. So for me, I like to tag my REPLs with the class that I am making a REPL for, and then I will call this week 2 lecture, and then I'll have a REPL where I sort of lecture and look at code while I'm at it. Okay, so this will be familiar to everybody from last week. For the most part, I just had you filling in the blanks. So we are going to, well, Do I want to take that out or don't I want to take that out? I'm going to take it out and get just a blank screen. Okay. So make sure that I've got myself in the right place in terms of the notes I made for myself. Yes. So, well, let me put it back. There it is. All right, what we're talking about this week is called variables. In programming, a variable is a named item that you can use to associate with information. The way most of us would think of this, I believe, that's the way I think of it, is that a variable is simply a place where I store data. And the reason why we call them variables is because we can change the data that we associate with one of these named values. If you've ever played Mad Libs, you've kind of used the variable. If you think about a Mad Lib is, I gave you Mad Libs last week actually. So what Mad Libs are is they create a sentence like my favorite food is blank. And then in the game of Mad Libs, you ask your friend, give me a noun. And your friend says, flowers. And then you take that variable that your friend just associated. So noun is the label and flower is the variable. You take that information and you plug it in where noun was, and now it says my favorite food is flowers. Is one way to kind of understand, if you're new to programming, what variables are. And they can be changed over time. So that their variable means that they may be the value, something may be the value 10 now, and then later it becomes 11, and then later it becomes 1,000. So variables are places where we store information, and their values can change over time. And I'm actually, yeah, okay, let me leave the hello world. I was going to switch it up, but I'm going to go ahead and leave it. So the variables are opposed to what we call literals. Because literals don't ever change. They just literally are what they are, and will be that when the program runs. So this hello world is called a string literal, and a string is any collection of characters. And we mark string literals with double quotes on either side. And when we say literal, we mean that is just literally what it is the text hello, comma, space, world, exclamation point. Every time I run this program as it is, it's going to be hello world. If I run it 100 times, it's always going to say hello world until such time as I actually change the code in the program to make it be something else. But a variable means that it's something that can change while the program is still running, which we're about to look at an example of. So a literal is just what it is. This one is a string literal. A variable is actually a location where we can store data and then change it over time. So let's do a variable. And they're going to look weird at first. Because there's more information that you might think going on with a variable. So here's an example of a variable in the Go language. A variable is, so everything on this line is associated with a single variable. You can tell by the coloring that some different things are going on. This word var, when things are in blue here, that means that this is sort of a feature of the language itself. It's not something that I have created or someone else has created. It's actually sort of embedded into the language. So this we call a keyword. And what this keyword var is how we begin the process of creating a variable. Var, not surprisingly, I suspect, stands for variable. So this is what I do when I want to create a variable, is I start with this keyword var. The next thing, here, I'll put the details. And we'll just break this one down really, really hard. So x is the name of the variable that I have chosen. So this part that's in black here, we call the name or the identifier of the variable. The identifier is the fancy name, is the fancy word to use for it, but you could think of it as simply the name of the variable. So it is a variable that I have chosen to name x. The name of the variable is entirely up to the programmer. So I could call this y, I could call it a, I could call it any number of things, and I'll show you a bunch of examples of the kinds of names that we tend to choose for variables. But the name that we choose for our variables is entirely up to us within the rules of the Go language. And there are rules, and I will talk about those. So I have chosen to create a variable. So I use this word var. I have chosen to name it x. A lot of us are familiar with associating x with values from math classes. No, Proxify, you're actually not that late, Proxify, because my computer literally crashed at 3:58 and it took me until 4:12 to get going again. So I'm not actually that far into it. Good to have you here. Okay, so var, because I want to create a variable. X, because that's what I want to name it. So var is not my choice. That is a Go language rule. X is my choice, because that's what I want to call my variable. Int is not my choice. Well, it is sort of, but within limits. So int let me say to store. So this word int, you'll notice that it's blue again. But what I'm saying is I want x to be a place where I store an integer, which is a whole number. So I want to create a var. I have chosen, because that is something I am allowed to do in the Go language, to call it x. I'm going to refer to it x in my code. And I want it to be a place where I store whole numbers, which we call integers in programming. So that is a Go rule. If you want a variable to store a whole number, then it is called an int for integer. And then this equal sign, you need to get used to this as a programmer, because it does not mean so there's a lot going on there. This equal sign, though, is not an equal sign in programming. We call that an assignment, and that's why this word assign is here. So what I'm saying with this symbol is I want to take what's on the right, which is the 99, and I want to store it in the thing that's on the left, which is my integer variable called x. Crazy, isn't it? That's a lot of stuff just to do that much work. So when this is all, oh, and then I have the 99 part. $99, which is in green, is the literal value that I am storing in my integer variable called x. So that's a lot of stuff going on in one place. And this is kind of what we're going to hammer away at this week is variables. How do I make a variable? How do I put data in a variable? How do I print the data in a variable to the screen? How do I change the data I'm storing in a variable? All that stuff. This is a lot of what we do in programming as we figure out how to store and manipulate information. Is a lot of what we do in computer science because computers are quite good at storing and manipulating information. Okay, so let's run down through the whole line. I have a variable. That's the go way of setting up to create a variable. I'm going to call it x, which in Go I am allowed to make that choice of the name of the variable for myself. I chose x. I want my variable to be a whole number or an int, which is short for integer. But in the Go language, when you want to store whole number information, then you use this keyword int to let Go know that's what you intend to do. So I need to tell Go that I intend to store whole numbers in x. And then I assign, notice it goes from right to left. So from the right side, I take the 99 and then I use the equal sign to store it in the thing on the left side, which is the integer variable x. Crazy, isn't it? Now let's print it out. And see what happens. So notice here, by the way, when I do the print line, so I have the string literal, which will literally be printed on the screen. Actually, let me change it so I can talk about it. And then I will also attach to the output the value of x. Right, so yeah, so Shamar asked, what if I wanted it to be like 99.00? Would that be a whole number? No, that's a different kind of data. So we'll do that next, Shamar. We'll do a decimal number is what we call it, what they call it in math. So yeah, we'll do that one next, but that's not integer. Okay, so let's print out the value of x. Notice, by the way, that I just put the x here outside of the quotes. So let's see what happens. So notice what happens. The value of x is 99. So what Go did when it saw a later reference to x is it put out its value. So this is important. You have to set up your variables before you can get their values out, right? So I did the setup first, and then I got the value out. So watch what happens if I move this. So I'm going to try to print the value first before I have set up the variable, and let's watch what happens. So there's an error. It says main.go, line 19, column 36, x is not defined. So if you see something that's undefined, what Go is telling you is you're referring to something called x that you've never set up. So, well, here's the x and the whole setup, which I'm doing after the fact. So let's move it back. So now I set up x first, and then I print it out. So there's a good question. How come the value of x isn't 99? Instead, is it x on the print line? Oh, this x. Yes. So this x inside of the quotes becomes part of the literal string. And a literal string is going to be literally what it is on the screen. So because it's inside of the double quotes, this x is simply the letter x that's going to be literally printed as a letter x. When I leave the x out of the quotes and Go recognizes that I set an x up as a variable earlier, it'll print the value of that thing. All right, so now we have an x. Let's change it. So one of the reasons why we call them variables is we can go back later to our x and we can make it something else. So you'll notice here, I don't do the whole setup on X this time. I just do the storage part. So remember, this equal sign is not saying equals to. What it's saying is take the thing on the right and store it in the thing on the left. And I know that's a little bit weird to think from right to left. It's just a habit of mine you have to develop. So my line 21 is saying take the literal value 33 and store it in the variable X. What happens to the old 99 is it gets overwritten. So the 99 is now gone. It has been overwritten with a 33. And if I come back and I print it again, and there, that's, someone pointed it out. There again, I'm putting the X inside of the literal string. So Go is just going to put literally an X on the screen. And that's because of the double quotes around it. Let me see if I messed up my mic on the camera. Okay, I didn't. Yes, so Proxify asks, should you always make sure you set up the variable first before you do the print line? And the answer is yes. If you don't, you'll get errors. And errors are okay, they have to be fixed, but basically you set up the variable first before you print it out. And then in this sequence, so I'm going to print it out with its initial value of 99 as the program's flowing from top to bottom. And then I'm going to overwrite it, the X, with a new value of 33 so that when I print it this time, it's going to say 33 because I have now overwritten X with a new value. So now notice the second time around it is now 33 because I have overwritten it. So this is one of the powerful things about variables, is that you can change them as you need to, as the needs of your program changed. It's hard to detect this because the program runs so fast, but the idea is that the variable X actually changed its value as the program was running. So it started out as 99, it printed out as 99 as the program was running. Then I overwrote it with 33, and then it printed 33. That's a variable with a value changing as the program is executing from top to bottom. So I'm going to mush all these up now. That is an integer variable. And you can create as many integer variables as you want. So you could have they can be negative. So I can set up another integer variable. Here's the setup, right? Var. I'm going to call this one y. You cannot reuse a variable name in a setup. So once I have set up X as an integer, it's always going to be an integer, and I can't change its setup going forward. I can change its value, but not its setup. So here I'm going to set up an integer variable y, and I'm going to assign to it the value negative 55. And why not print it out? So I can say, and y is y. And y is now y, and let's change y to, I don't know, -1. Or let's switch them around. Let's make the x be negative and the y be positive, just to prove that they can both be negative or positive. So here's the setup for x, 99 to start, for y, -55 to start. I'm going to print them both out, and notice how I constructed the output. So I have this literal string, the value of x is, then I have the x without the quotes around it, which means that Go is going to go fetch the value and put it here. Then some more literal string, and y is, and then the value of y, since it's not in quotes, Go is going to go fetch the value and print it. Then I'm going to overwrite x with negative 33. I'm going to overwrite y with 22. I just picked those values at random. And then I have another print where I'm going to print the value of x is now literal string. So literally what's in the quotes. The value of x, more literal string, and then finally the value of y. And there we go. So the value of x is 99, which is what I started it at. Negative 55 for y is what it started at. And then notice the second output, after the changes, they both show their new values. So that is integer variables in action. Let's do some float variables in action. Yeah, so here we go. So we call them floats, which I will talk about, but let's make a, let's do a little bit fancier variable name. So I'm going to say price. So the name I'm going to use for my variable this time is descriptive. And what I mean by that is the name suggests the purpose of the data. So you can probably, your mind already probably did it, thought he's going to store information about the price of something in here. And that is in fact true. So I'm going to say price. And since this is going to be something like 1.25, let's say $1.25, that's not a whole number anymore. That is what you would probably call a decimal number from math class. But in programming, we call it a float. And I don't know why it's not turning blue. It should turn blue. I don't know why it's not turning blue, but we'll worry about that in just a moment. Although it bothers me it's not blue, but maybe it's because I haven't finished the line. It's not. Not float. What do I want? I'm getting confused on languages. Apologies. Yes, float. Think. I'm thinking. Oh, yeah. What am I thinking? Sorry. I want to call it a float for your benefit, but Go doesn't call it directly a float. So, it's an F32. Is it a float 32? There we go. Gosh, darn it. Okay, so sorry. I would rather it not be this way. Because the 32 is going to be off-putting to you. In fact, we should probably use a float 64 yes, it is for bits. You're right, the damn bar. Yeah, and you're going to find that float 64 is sort of the common one that's used. For people who are new to this, I wish it were just plain old float, but that was wishful thinking, and I forgot you have to put the bits. Yes. Okay, so don't worry tons about the 64, even though it has to be there. Worry about the float part if you're new to this. When we have a decimal number, bits. So, yeah, so someone made the comment, does that 64 have to do with the bits? So the 64 is referring to the amount of space that is required to store it in the computer. So there's a 32 one and a 64 one, and the 64 requires more space. What you get for the 64 is greater precision, so you can go out to more decimal places accurately for 64. But for our purposes, even though we have to have the 64 there, it's the float part that's important. So a float means that we want to do a decimal number. But what we call them in computer science is floating point numbers. And the idea of a floating point number is that kind of the decimal can appear in different places depending on the value of the number. So we call them floating point numbers. In computer science, in math class, you'd call them decimal numbers. So when you want to store a decimal number, we're going to use float 64 in this class. Sometimes you'll see float 32. As long as the word floats there, then you know that what we're talking about is a number with a decimal point in it. So var again, what was the word I used above? Keyword to create a variable. Price, which now I got to adjust these to line up. And the identifier or name I have chosen for the variable. Oh darn, this one's going to throw off all of my spacing. So the idea here is that we have different variable types for different information types. So if we're just going to store a whole number, that's an int. If we want the possibility of doing the decimal places, then we need a float. And then 1.25 is, what was the words I used above? The literal value I am storing in my float 64 variable price. I'm going to talk about the naming part a little bit more here in a bit as well. Okay, so I am storing a different kind of information, not whole numbers anymore, but numbers with decimal points in them, which means that I'm going to use a different type. The type I'm using here is float 64. There's also a float 32. But I think generally we will opt for float 64, which I'll explain. You'll see this come up again, and then I'll explain to you why we made this choice today in just a couple weeks, I think. But otherwise, kind of the same deal here. So the price is price. So the price is $1.25. It would look cool if there were a dollar sign in front of it. So I'm going to put a dollar sign in front of it. In the literal string, I put the dollar sign, and then right after that is going to come the price. You'll notice there's a space here. And there's I don't think I can do anything about the space. Yep, I can't do anything about the space. We're going to talk about how to get rid of that space right there. So you may have noticed when I'm printing things out. So notice the literal string up here, the value of x is, there's no space at the end, but go put a space in the output. And then after it, before the and, go put another space. So around these variables, when the values are going out, Go is putting spaces. It puts spaces around this X here, even though I don't have spaces in the literal string. Go is putting spaces in there. But in the case of this one, I didn't actually want a space, but Go is putting it there anyway. So we'll talk about what are our options for not letting Go just put spaces, because Go wants a space, even though I might not. But we'll worry about that in a moment. So there's a float. I can change it just like I would. Let's be topical and have some inflation. So I'm going to overwrite the variable price, and then I'm going to print it out, and it will show a new price. So the price is now $2.49. And you'll notice that there's a space, even though if I take the space out here, So there's no space between the $sign and where I do price, although there is that comma I have to place there. Go still puts a space. So I would prefer it not do that. And before we leave tonight, we're going to take control of that situation for ourselves. Okay, so there is a floating point. We can also store, I want that as a reference so I can kind of use the same words. We can also store strings if we want to. And strings just means text. Text that when we print it is text on the screen. So we have literal strings that are in double quotes, but we can also have variable strings that we can change over time. So now I'm going to make a variable. So I use the word var because I'm setting up a new variable. I'm going to, name it product. It is going to be a string or text, and then I'm going to assign to it, remember right to left for when we store data. I don't know, what am I selling for $2.49? A candy bar, let's say. I don't want to capitalize it. A candy bar. And let's go through the same breakdown. So var keyword to create a variable. And you have to create the variable before you use it for anything like printing it out. So you have to set it up before you can do anything like overwrite it or print it out. I have product, which is throwing off the spacing, which is the identifier. That's the fancy word or the name I have chosen for the variable. I have string, which is I want to store a string or text. And then finally, candy bar with double quotes. Notice, let me line these up again. It's just worth the extra trouble to make it look just a little bit nicer, I think. Candy bar, which is the literal value I am storing in my string variable product. So hopefully everyone's following that. So we've looked at 3 different kinds of information and how to make variables for storing them. Integers, which is whole numbers, negative and positive. Floats, which is floating point or decimal numbers. And now strings, which is text. And notice that the way when we store information into a string, we store it with the double quotes around it because that's how we represent the values. We can print them out. Oops. Oops. Forgot an extra quote in there, I think. Yep. Product. So literal string, which just literally then appears on the screen as the product I am selling in is. And then product, which Go is going to recognize as a variable I set up. So product I am selling is candy bar. And I can do the same thing with string variables. I can go back and say for $2.59 or $2.49, I should sell something else. A really nice candy bar. And then I can print that out, the overwritten value of the product. So now the product I'm selling is now a really nice candy bar. I should have said a candy bar here. Yeah, that's what I want. Okay, so there is string variables. We don't need them yet, but we also have a specific variable for storing the value true and the value false. We call those Booleans. We don't need them yet, but there is one more kind of data we will store in this class that we will create variables for that we call Boolean values, which are true and false. But I'm not going to mess with those right now because these are the ones that we really want to have at hand. But that's what in the notes on the lower right, you can see that's what bool is referring to. You will see them in your reading. What we want to focus on, though, is integers, floating points, and strings, which is most of what we do. Okay, so there is the basics of variables, and that's the kind of stuff I would have you. This approach is what I think is the easiest to teach because I think it gives you all the details. It's not hiding anything from you, and it sort of gives you all the information that we associate with the process of creating variables, printing out the values of variables, changing the values of variables, and then printing out the new values of variables. Is all of that stuff. So now I'm going to talk a little bit about some of the other things that you are going to encounter as you read through the readings this week. So as a teacher, I personally prefer the ways that we just talked about for creating and using variables. But remember when I was saying at the beginning that Go gives you a lot of options here. So now let's look at some of the options. And then you can kind of decide for yourself if you think the options make sense or if you like the sort of the highly detailed approach. I personally like the highly detailed approach, which is var, name, type, value approach. But it turns out that Go has some shortcuts for doing all of this. And I'm going to show you some of the shortcuts. So here's a shortcut. I could do this. So hopefully you notice what's missing here is the word int. And I don't like that because when I'm teaching, I want people to learn what an integer is in programming and what it means. And I want people to learn what a float is, what a floating point number is and what it means. And I want people to learn what a string is and what it means. But it turns out in the Go language that if you leave the type off, then Go will infer that in this case, quantity is an integer. How is Go inferring that quantity is an integer? Maybe I can ask in chat and see if anyone's brave enough to venture an answer here. By infer, I just mean Go will figure it out for itself. So what about this setup allows Go to make the assumption that quantity must be a whole number or an integer? Well, var tells Go that I'm setting up a variable, so that's good to remember. Okay, so Shadowhunter, you're on to something. I didn't say 10.0. And what kind of information is it that's only a whole number? That's right. So the Dambor sort of followed up on Shadowhunter's thought. Because 10 is a whole number, Go assumes that I want quantity to be an integer, or it infers that quantity is intended to be an integer. Now, I personally don't like teaching it this way, but you are going to see it in your reading. So Go does have the ability to infer the type of data that you are storing based on the type of data that you store. Now, at this point, quantity cannot be anything other than that. I cannot go back later and change it into a float. Once Go has inferred the type of quantity, then it is that type integer forevermore. So I can also do all of the other types this way. So I can say var percentage equals 75.0. And in this case, Go will infer that percentage is a float. And it will do that based on the information I'm storing in it when I first create it. Because that decimal point is there, that allows Go to infer that percentage is a float type. And it can do that for strings as well. No, nickname. What do I want? Uh-oh. I don't know what that was. I'm having all kinds of computer fun tonight. Animal equals kangaroo, let's say. And in this case, Go will infer that animal is a string. So this is an example of an option for creating a variable where you don't actually enter the data type into your code. You let Go infer the type for you. There's nothing wrong with this approach, by the way. A lot of people use it. I just don't like teaching it because I feel like there's information that I want you to see that you can't see necessarily. But I also think you should know that Go allows you to do this. So this is Go being allowed to infer the type of these variables. Another thing that Go will do I'm having trouble typing. That's a good question, Shamar. Shamar asked if Go is inferring the type. I think it is going to be a float 64 that Go would infer, just because so much of the other areas of the Go language kind of expect a float 64. So I suspect that you are correct, that it will infer more precision in terms of 64 than less precision in terms of 32. I suspect you're correct. Okay, so again, I don't like teaching it that way, but I want you to know it's there, and you're going to see it in the reading, and it's perfectly valid. I don't like the information being hidden from you when I teach. Yeah, so Go doesn't like it when you create variables and don't use them ever. So if you just declare or create a variable and you never actually use it for anything, Go's going to want you to get rid of it. So let's use it for something. Let's see, we have quantities. So the percentage is percentage, and then I'm going to put a little percent sign after it as a literal thing to print on the screen. And then I will say format.println. I would like to see a animal, which in this case would be a kangaroo. Thanks, though, for bringing that up, the Dan bar. That if you create a variable, Go's going to make you use it, or it's going to make you take it out. And notice, by the way, the 75 with the space here. So Go is putting a space, not me. And I don't like that, but we'll address that before we quit for the night. Okay, so this is inferring the types. And then there is actually a shortcut that Go allows where it infers the type as well. And here's what the shortcut looks like. Let's say I don't know. I haven't bought gas in a bit because I haven't been driving very much. But you guys are probably paying a lot more than that. I don't know what your gas prices look like, but let's say $5.89 or something, which is probably a bargain. Okay, so there's also this last method of creating variables where if you use the colon equals, that's a shortcut for the entire process of creating a variable. So you will see this in your reading as well. You won't see me use it much in class because, again, I think a lot of information that I want you to be aware of is hidden. But this is another way of creating a variable. If you use colon equals, then you're telling Go, I'm creating a variable, and I want you to infer the type. So this will be price per gallon is a var price per gallon float 64 589. So this is another way of creating variables. So that colon equals is special. You only use it when you first create a variable. You don't come back and use it to overwrite those variables. So we'll do that. Let's do a big old long output here. So we will say I bought gallons purchased of gas for price per gallon. And what I'm going to do here after the comma is I'm going to go down to the next line and I'm going to continue from there. From gas station. Yes. So the Dan bar has a really good, and I know if you're watching the video later, you won't see it. But this whole line right here, would be var price per gallon float 64 equals 5.69. So yeah, good point, Dan Bar. Thanks for putting that in the chat. So this shortcut, price per gallon colon equals 589, is the short form of doing what would otherwise be var price per gallon float 64 equals without the colon 5.69. The way you're going to see me do it, at least for a while in class, is the long form. Again, so we don't have information that's hidden from us and we're reminded that I'm creating a variable. I am naming it price per gallon. I want it to be float information, meaning it has a decimal point in it. And I want its value right now to be 5.69. So yeah, thanks for saying that in chat though, because then I can put it in the notes. Okay, and then notice I've made this big old long print line where I have sort of mixed in literal string, comma, value of a variable, comma, literal string, comma, value of a variable, and then I got way to the end, so I just pressed enter and then continued on the next line, literal string, comma, value of a variable. And it doesn't look great because there's a space after the dollar sign. It could be worse. But it's not my favorite that space is there. So I bought 10 gallons of gas for $5.89. Well, per gallon. Not for, that would be like 50 cents a gallon, which sounds like more like when I was a kid. Where I could fill up my little 1 gallon gas can when I was mowing lawns for like 65 cents. Okay, So there's a long output, and I have just pressed enter when I got kind of the end of the screen, just so it didn't run off the screen and make a big mess. And then I continued on the next line down. You can also break it up over many lines if you want to. It's a little bit harder to keep track of if you do that for some people, but anyway, notice that is one output with a whole bunch of stuff going on in it. And then I'll just remind you real quick that when I go back later and let's say the price of gas, well, like as not, went up. I don't use the colon equals now. Now I just have a variable that I already set up earlier. And now I'm just altering its value for later use. Oh, is now, is no. Well, I say no to that, but now is what I meant. Okay, so all of that shortcut stuff, because you're going to see it and probably asked a question or two about it so that you are familiar with it. So we have this sort of dramatic shortcut for creating variables, which is the colon equals and the type is inferred based on this part. We have the slightly less shortcut, which is really just creating variables where we allow Go to infer the type. And then we have the long form of creating variables where we say var, the name of the variable, the type we want, and then what we want the value to be. Okay, so that's a lot of stuff. I'm doing all right on time. I'm not doing great on time, but I lost those basically 15 minutes. So sorry about that. And I hope I'm not trying anybody's patience, but I'm just going to keep motoring on because I want to leave you with all the content. So, all right. So there is a whole bunch on just creating variables. And when we say that in programming, we simply mean that we are creating named things that we can use to store values, and we can use those to also change the values as the program is running based on our needs or our wants. So we call those variables. You've seen variables in math class. They're really just labels that refer to a value of some sort. You've solved for X probably at some point. So same kind of idea there. Okay, so now let's talk about, and I'm just going to keep going down the screen. So what we'll end up having is this just gigantic code sample that I'll post in the lecture for you to look back on if you choose. So let's keep going. Now let's talk about zero values. And I'm going to go long form quite on purpose. So Go will actually allow you to create variables and not give them, at least appear not to give them any initial value. So here I've created a variable. I have named it some number. I'll talk about the naming here in a moment. I have named it some number, which I'm trying to double click on. And it will be an integer, but I have not used the equal sign to assign it any particular value. So let's see what happens. So you'll see that the value of some number is 0. So if you create a variable in Go that's an integer variable and you don't give it a specific value, it will be 0. That's what we call zero values. That one's pretty obvious, I think. Like that's what most of us would do, is if we saw a whole number and it didn't have any apparent value associated with it, we'd assume maybe it's 0. Let's try another one. So var some percentage float 64. Let's see what that looks like. So the value of some percentage is 0. By the way, you'll notice that it doesn't look like there's a 0.0, even though we have a sense there should be, because it's a float, a decimal number. And that has to do with the way we're printing it out, and I'll show you how to take control of that before we leave tonight. So if you create a float variable, so var to create it, some percentage is its name, I want it to be floating point, and I don't give it some other value, then Go will zero it out. It'll just make it be 0. Now let's look at what it does with the string. So what if I create a string variable and don't give it any initial value? What happens? You'll notice this last output on the screen, there's nothing there. So I'll put a little note here. The 0 value of a string is basically, you can picture it as just double quotes mushed together with nothing in between them. We call that an empty string in programming. So Go will give your string a value, and it will be the empty string, as we call it, but that's really just, imagine it as double quotes with nothing in it, not even a space, just nothing. That's called empty string. So the idea here is that you can create variables in Go, and if you're okay with them starting at their 0 values, then you can just let them be their 0 values. You can, of course, if you want to, manually 0 them, but if you don't manually 0 them, then Go will 0 them for you. So there's a reference in the reading to these 0 values, and that's what that's talking about. Is if you don't make it anything, Go will make it 0 for integers. If you don't make it any value, Go will make it 0 for floats. And for strings, if you don't make it any particular value, Go will make it empty, which is not even a space, just double quotes with nothing in there, which we call in computer science the empty string. Okay, so there's that part. And yeah, I'm running pretty good. But I think I actually am going to get into an hour and a half roughly, just because of my delay, because of my computer crashing, which is very disturbing. If you've ever had that experience, you think, oh man, when's this computer completely dead? And you know how disturbing that is. Okay, so there's the 0 values part. That's a lot to absorb. I personally, as a programmer, am not a good absorber, meaning that I'm not so good at going and reading about a programming concept and then just thinking about it and having it kind of stick in my head. I need to sit down and type it onto the screen and click the run button and see what happens to develop a sense of how it works. Oh, I feel pain for you, Soren. So Soren in chat says they've had that, like tons and tons of the computer just completely bombing out on them. I'm going to have to scrap together the money and buy one, and I hope the conditions with computing purchasing being what it is, that I can put my hands on something affordable fast, or I'll end up having to do the live stream on a laptop, which isn't my favorite. So yeah, I feel at least a little bit of your pain, Soren. Okay, so let's talk a little bit while we're at it about how to name variables. And I'll give you sort of the rules of thumb. Well, I'll give you the rules. You cannot start a variable name with a digit. Because Go can't figure out that the digits aren't supposed to be a number, and they'll just think you made a mistake and you'll get an error. So you cannot start with a digit. You cannot have spaces in the names of your variables, such as my space favorite space number. You will get an error when you do that, because the spaces to Go are how it detects the moving on from one element of your code to another element of your code. So Go is going to think that my is the name of a variable, and then see a space, and then see a word that makes no sense to Go. So you cannot have spaces. They should be descriptive. So you'll learn this as we go through the semester, but we try to write code that is somewhat readable to people, especially other programmers. So if we have a bunch of variables that are like X, Y, Z, ZZ, RB, N, those aren't really readable. They just seem like garbage on the screen. Whereas if we use variable names that are descriptive, like quantity purchased, then someone reading our code will see that variable and say, oh, I bet that is information about the quantity of something that someone purchased. That's what we mean by descriptive. Notice that there isn't a space between quantity and purchased, because you can't have spaces. And so we'll talk about the next concept, which is they should be camel cased. For example, so since we can't have spaces when we name variables, but we want them to be descriptive at the same time, we do use multiple words like first name, last name, favorite color. And the way we make the words a little bit more readable on the screen in Go is to use what's called camel casing. And by camel casing, what we mean is whenever we switch to a different word, even though there's no space, we put a capital letter in so that it becomes slightly more readable. Hopefully everyone can kind of see that first name is camel cased and also kind of more readable because of that. Same for last name. It's descriptive and it's camel cased, which makes it more readable. Same for favorite color. It's descriptive. It must be information about someone's favorite color, and it's camel cased, so that it makes it more readable on the screen. You can use underscores, but in the Go language, we don't much use underscores in variable names. We don't really need them to space things out or make them more readable, because we tend to use camel casing. But you can have underscores in your variable names if you like them. Even though that's not considered good style in Go. So I'm not even going to leave it there for the notes later. Just pointing out it is legal to use underscores. It's just they're not much used because we prefer in the Go language the camel casing style. Okay, we're down to controlling our outputs. I'm going to give you a couple examples here, and then I'm going to quickly switch over to the second lab and get us started on it, and give you a couple examples in there. So how are we on time? So I'm into what I hope is about my last 10 minutes to account for the fact that I started about 10 minutes late. I'm sorry about that. I understand people have to come and go. The video will be there. And hopefully that doesn't happen again. I hope I get a new computer before the whole thing just completely dies on me. But anyway, so let's talk about better control of your output, which is what we want. As programmers, we want as much control over what's going on in our code as possible. And I'm going to refer back to an earlier example where I had, let me just, wait, do I have some variables I can use? Price per gallon. So let me just return you, well, actually, let me do it again. And let me just sort of explain to you what I object to about the whole thing. So the price per gallon is $, price per gallon. And it doesn't matter if I have that space there or not. You should have the space there because it is considered better programming style to have a space after a comma, like you would in writing an English paper. But I'll take the space out and just point out to you yes. So you can put spaces in the literal, you can. So Shamar asked, can you put spaces in the literal string part? And you can put spaces anywhere in here that you want extra spaces. It's a good question. And so we're going to get up to, I'll show you several examples of that. But let's start with this. So I don't have a space. I do have to have the comma because it's a Go rule. I'm switching from a literal string to a variable value, and the Go language requires this comma to be there. Pardon me. But notice I don't have a space, but when I print it, Go puts a space in there, and I don't want that space in there. That's just completely irritating to me. So we need to take control over this output more than we're given with print line. Now it's going to be scary looking at first, but you want to learn how to do this because a lot of languages allow you to do this same thing that we're about to learn, and you have complete control over your outputs, which is what you want, because you want your outputs to reflect the amount of effort that you put into your program. So you're working hard on code, most of which no one's ever going to see. They are going to see the output, and you want the output to be as good as the code that produced the output. So here's what we're going to do. We're not going to use the print line or print ln style. We're going to use the print formatted, pardon me, or printf style of printing. It's going to look weird at first, but just with a little bit of practice, you'll find that it feels natural to have complete control over everything, including the spacing. So here we go. The price per gallon is $, and then what I would like it to look like is this. In fact, yeah, so 5.69, right? This is what I want it to look like when I put out the price per gallon. But I don't want to just literally type 5.69 because the price per gallon may have changed to something else. Let's hope, for example, that maybe it would be, something way less, which would be super, super nice. Okay, so I'm going to switch the way I'm doing the output, and this printf style gives me complete control over the quality of my output. I control the spaces where I want them. I control everything about the output. So the way we do this is with the printf style, we find the location in the string where we would like our information to appear, which is right here after the $. We put a %. And then we put the kind of information we're plugging into that, which is going to be a floating point, I think. Yeah, it is. Price per gallon is a floating point. So this little thing is weird. And I will put a comment on it. So what's going to happen is when I'm using the printf style, price per gallon, this %f is a placeholder for price per gallon. And when the program runs, Go is actually going to take the value of price per gallon and it's going to plug it in where that placeholder lives. And I want you to notice the difference between the print line form where I don't have as much control and the printf form where I have full control over the output. Two things are different. Wait, where'd it go? Let me run it again. Okay, so there's a few things going on here. Two of them are disturbing, but one of them is not. So one thing you'll notice is that the $ is right next to the price per gallon now. And that's what I wanted. I wanted that kind of control. Something that I got that I didn't necessarily want is these extra 4 zeros and the fact that this little yellow arrow is sitting here suggesting that we need a blank line somewhere in there. So %f, that's called a formatting verb in the Go language. %f is a placeholder for a float. So it is a formatting verb for a float. But what it does is it serves as a placeholder for whatever is over here. So price per gallon gets plugged in where the formatting verb is. So the $ is still a $. The %f is a formatting verb that gets plugged into. So notice that the space went away. That's what I wanted, but I get not the 2 places after, not the 0.95, but 0.9500000. So I kind of lost part of what I wanted. But it turns out, and this is going to be the part that's a little bit scary, so just get used to what it looks like. I can go into my formatting verb and I can put a decimal point and specify how many places after the decimal point that I want. So let's try 4 places past the decimal point. So now I have a fancier formatting verb, which says % 4 places after the dot, a float. And then price per gallon gets plugged in there, and then 4 places after the dot. Which runs and then does some kind of weird, there it is. So this is a slight improvement. $2.95 with no spaces, but now I have 0.9500, but that's because after the dot I have 4 places for the float. So after the dot, 4 places for the float. So does anyone want to venture a fix? So how do I get the places after the decimal to be just 2 as we would expect to see for the price of gas? Nice, the damn bar. So 2 places after the dot is exactly what we want for something like outputting currency values. So now it's 295 after the, and we can do, so this, it takes practice. It takes a lot of practice. One thing I'm going to add to it though, at the end here, so once the F, so this is the formatting verb and it's all one placeholder. So after it, I can actually add additional things. So I could, for example, put a period at the end of the sentence because the F is the end of the formatting verb. So if I run this, you'll see it's a complete sentence now with a dot at the end. So the reason why %.2f is not being literally printed is because Go has been set. This printf knows to look for these formatting verbs and use them to be replaced with stuff. So it's because Go is designed to handle it that way. So Go is looking for these formatting verbs. When we have a printf, Go knows to look for formatting verbs and use them. There's one last thing that I don't like, which is that the little caret at the end of the line is sitting there. Yes, so the % is a marker that Go uses to locate formatting verbs. Good one, the damn bar. So I added the dot. Now I'm going to add a manual line break. So this is a backslash, is what we call it. It's over your left pinky up there with the vertical bar key. But this is telling Go, oh, also add an extra break at the end of the line, or a new line, as we'd call it. So when I run this one, you'll notice that the caret is now on the next line down because Go put a line break. So this is a lot to take in. There's a lot going on there. You're going to get a lot of practice in Lab 2 at doing the printf style, because in Lab 2, that's all we're going to do is the printf style. So I'm going to switch over to Lab 2 now and get you started on that in my last few minutes before I before I stop the stream. And I'm going a little bit long, so thanks for your patience. So we want to control our outputs. And because I want you to learn how to do that, I am requiring that you do it. So this code is going to go up as a sample. In fact, let me just get it real quick. Let me put it over here. And I will post that on the lecture page. All of that stuff we did with all of the comments for later use. But I'm going to go back. I'm going to create another REPL. So a Go REPL. I'm going to call this CSCI 20 Lab 2. And I'm going to go a little bit faster here. So what you're not, well, you're going to see me do it actually. So let me go grab the code for it. You've all done this once before. And then give you some helps to get started. Okay. Stretch this out so it doesn't wrap. Okay, so the nature of Lab 2 is to practice creating variables and to practice printf outputs. So notice this note at the top, use printf. I'm going to know who did and didn't watch any of this video today, this week, because they will use printline and not printf. Printf is a requirement in this lab because I want you to get practice with it. Before things get more complicated, I want you to feel like you have some mastery of full control of your program's outputs, which is what we want. So, but let's do some and just see what it feels like. And I will do different ones so you can see the verbs. So declare a string variable and assign it the value of the current day of the week. So I'm going to make a new var here. I didn't do the documentation, but you should. Full name, the date. So I guess I'm doing the documentation because I want you to do it. Okay, so number 1, create a string variable. Assign it a value of the current day of the week. So when you're naming a variable, you can kind of just use the description of what it's supposed to be as your name. So I would probably call it like day of week. Most of us will start with a lowercase letter on our variables and then camel case through it. So notice that the of camel case and the week camel case. It will be a string, and then I want to assign it today, which is Tuesday. Let's do this whole one so that you can see one going on everywhere. So let's build this out a little bit. So this message is going to be a big, long, scary one. So let's do this. So we want to do a printf today is day, month, space date, comma, year, period. And then, but we want it to be actual stuff. So let's try it for day of the week. So I declared the variable, and now I'm going to go down to this print message, and I want to put day of week in here. But I need a formatting variable, a verb, to do that. So I need a placeholder in the correct location in here for where the day of week goes. Well, that goes here where day currently sits. So instead of day, I want to put a formatting verb, which starts with a %. And then we match the formatting verb to the kind of data that we're going to print. Not all the formatting verbs are intuitive, but for strings, so day of week is a string. The formatting verb for a string is S. Let's see. This one's going to give me an error if I try to run it, so I'm going to disable it and then run it. So I'm disabling line 40. Nice one, Shamar. %S is the formatting verb for a string. That's right. And then day of week will plug in. I went down to line 40 and temporarily disabled it because if I don't, it will give me an error. So the way I disable the line is I just put a // in front of it. Yes. So Shamar, that's correct. Good one. I comment. The way we describe that is commenting it out. So I am using a comment to disable this line of code, or I commented it out. And the reason I did that is because the Dan bar pointed out earlier that if I don't, I'm going to get an error. So I'm going to comment line 40 out, and then I'm going to run the other code that I wrote, which just includes the day of the week and the print statement, only plugging in the day of the week right now. So today is Tuesday. It went in there. Month, date, year are still just month, date, year. So the only one that got plugged in is the one with a verb, day of week. So let's keep going. Number 2, a string variable for the month. So I'm going to just say month, which will be a string, and the month is currently August. And now let's go plug it in. So the way you do this is that the formatting verbs and the variables go from left to right. So the first %S is day of week, and I want after that the month. So the second %S will be the month, and I will put that right here where it says month. So the first %S is the first variable in the list. The second %S is the second variable in the list, going left to right. So it should say today space is space plug in Tuesday, comma, space, plug in August, space, date, comma, space, year, period. Let's put a new line on it so that there's an extra line break at the end of the line. So notice down here at the bottom, the yellow caret is after the dot. We're going to make that move down. All right, let's see if the month got in there. So today is Tuesday, comma, August. So it plugged in left to right as expected. Line 40 is still commented out, and don't forget it's commented out or disabled. All right, so now number 3. Declare an integer variable with the date. All right, so var. The date, I'll just call it the date. It will be an integer variable, and it will be today's date, which is the 30th. Then we will go down and plug it in. They plug in from left to right. So left to right, the next one in line will be the date, which is what I called the variable. So now we have to switch because the date is not a string, it's an integer. So I cannot use %S this time because the date is an integer, it's not a string. So %S works for day of week because it's a string. %s works again for month because it's a string, but the date is not a string, it is an integer. Unfortunately, the formatting verb for integers is D. You can think of that as a base 10 or a decimal number, or you can just kind of remember that the verb for an integer is D, which is true in other languages, by the way. So this is not weird. It's weird, but it's not weird to go. It's weird in programming. So now going left to right, I will plug in a string, day of week. I will plug in the next thing, which better be a string, it's month. I will plug in the next thing, which better be an integer, which is date. So there's August 30th. And then let's do number 4, which is the year, which is an integer, which is 2022. I don't think %i is anything, the damn bar. I think %i is probably nothing. I'd have to look into it to see if that has a meaning as a verb. I haven't used %i as a formatting verb, so I don't think that it is anything. But maybe it is, and I just don't know what it is or can't remember. Okay, so let's fill in this last one. So after the date, going left to right, is going to come the year. So the first %s, day of week, it better be a string, it is. The second %s is month, it better be a string, it is. The third, which is a %d, better be an int, and date is. Year should be replaced with year, which is an integer, which is also a %d. So I'm plugging in 4 different things in order from left to right: a string, an int, and they better be a string, an int, which they are. So it should just run, and I get a nicely formatted, scary looking at first, but once you get used to it, then it seems like a clean and elegant way to do it, really. Quite nice. Okay, so that I'm going to now re-enable the temperature. Give you a hint on that. Oh, I already did give you a hint on that. So much of what is left, you now know how to do. So I did all of steps 1 through 5. Step 6, you now know how to do, I hope. You're already given a temperature variable. And I want you to notice on line 9, it does not say create a temperature variable. It says reassign the value. What that means is you take your original temperature variable and you assign it some different value, like perhaps a temperature that you'd like to see. So when it says reassign the value, it means reuse your other variable, but with a different value. Okay, so we've seen all the formatting verbs: %s for string, %d for integer, which I know is weird. It's in your reading. And then %f for float. And there's a hint in here on line 44. %f, it turns out, has a little bit more power built into it in that we can control the number of places past the decimal as a part of the verb. And there's another hint on line 56 that is similar to that. So I hope that that is enough to get you going. I'll put both samples, so there'll be 2 coding samples. One will be the Lab 2 sample, and one will be the lecture sample on the lecture page. So thanks for bearing with me for so late into the day. We're closing in on 2 hours. Sorry we didn't get a break. I was feeling a little bit stressed about the crash, and then I also just wanted to make sure I got all of the content in all of the detail that I hope is necessary to have you a good understanding of what's going on. So what I would say about all this is you're probably going to see errors when you try to run the program, and that's fine. You go and fix them. If you can't figure out how to fix them, you can put questions about it in Piazza for everyone to see and share. You can send me questions in Canvas inbox. And remember, I also have office hours on Thursday. So Dark Bandit asks, what if you put 2 %? So What, for example, would happen if I put all of these formatting verbs on line 33, but only one variable to plug in? Let's see what happens, and then we'll call it a day. So, oh, it's complaining about all my variables. All right, let me disable them then, because I want to see what line 33 will do with more verbs than variables. Oh my goodness. You're just killing me, Go language. Okay, so there's what happens. It actually kind of went through to the end and then just tells you that you've got placeholders or verbs that are missing variables to plug in values for. Excellent question, Dark Bandit. That was totally worth, seriously, that was worth quickly exploring to see what would happen. So if the number of variables doesn't match the number of verbs, it looks like Go will proceed and then gripe at you that you're missing some values that it wanted to plug in. Cool question. Okay, so 2 sets of samples on the lecture page. Office hours is always on Thursdays. There are one-on-one sessions available, plus the just open drop-in from 4 to 5. Canvas inbox if you have questions. Piazza is a great way because often you have classmates that get there quicker than I do and provide an answer. And also, if you contribute a question in Piazza, you are creating opportunities for other people to help and for other people to learn as they get the same answers probably that they were looking for that you are. So thanks for sticking it out for all this time. I'll get the videos up as fast as I can, hopefully without any more computer crashes. And then I will be available at office hours, and I will see you again next Tuesday. We did not talk about the first project. We need to prioritize doing that, so I might put that up front next week. So we make sure to get to it. But I wanted to give you a lot of detail about this stuff. So there you have it. Take care and have a great week.